All right, hey guys, we're going to look at solving trig equations and solving for x. So, um, in some to some extent, it's fairly straightforward. Can be a little bit complicated at times, but hopefully, how I'm explaining today helps you. And I'll probably put a few extra links to other great YouTubers, YouTube teachers who'd be able to probably explain things a lot better than me. Okay, so I want to show you exact values, and without going into any of the detail, I'll probably just quickly, where is it, show you here. I guess working out what is the sine of 30, sine of 60, what is the cosine of 45. You get these exact values looking at these diagrams. So you could pause, you could have a look at it, see how certain exact values using surds have been derived, Pythagoras theorem, and then we get these things, okay, and based on the unit circle. So let's get back to this. So when we have these exact values, this is kind of like a basic timetables for trig functions. It's very useful to know that, okay, well, sine of 30 is going to be half, sine of 45 degrees is root 2 over 2, sine of 60 is root 3 over 2. And then if you were to try to figure out a pattern, I guess you could see that root 1 over 2, root 2 over 2, root 3 over 2 for as you go along with sine. And then root 4 is just going to be 2. 2 over 2 is 1. Okay, so there's a pattern going with sine. Then with cosine, it is basically the reverse of sine. So you're starting off with 1, moving on to root 3 over 2, root 2 over 2, 1 over 2, because root 1 is just 1, and then 0. Okay, and then when you have tan, you start with 0, you got root 3 over 3, and then you got 1, and then you got root 3, and then undefined. Okay, so just something to look at there for your use. And I'm going to use these examples to help work out what x is with these equations. So to work out what the degree is, okay, what that angle is, to work out root 3 over 2, we can see that, let's just go inverse sine of root 3 over 2 is what we would normally do to approach working out the angle. Root 3 over 2, we can see from this table, is 60 degrees, okay? But what we need to keep in mind is that we've got this domain, we've got this range from 0 degrees to 360 degrees, and let's see if I can go back to here. Okay, so let's say this was 60 degrees here, okay, then that would be your exact value. We can say that it's going to be the same value over here, which means it's going to be that angle there. So 180 minus 60 is going to give you 120 degrees for this theta for the same value. Okay, all right. So let's head back to this. And it's always useful to look at the graph as well. Use your calculator, see how it makes sense, and I will show you also how to do that on your calculators, and then probably use Desmos to give a bigger view. While we're waiting for that, let's get the calculator out. So here is sine of x, and I have basically popped it into the calculator, into the graph. So when you go into menu, so you go to menu, graph there, and then you'll end up getting to the scratch pad. Now I lost my place. There we go. Now looking at this, now if you want to know how to get, once you've typed it all in for that graph, you would have something completely different that doesn't look the same as what I have right here now. So what you want to do is go to menu. You want to go to where is it? Window, okay, and window settings. And from window settings, you would want your X values from 0 to 360, and then you could have your Y values as minimum -2 to +2, and then that will just recalibrate the window appropriately to that range. Okay, so let's get back to this here. So we know that we've got 180 minus 60 is going to give us 120 degrees, because 120 degrees and 60 degrees is going to give us root 3 over 2. Okay, so if we look at this calculator, actually what I'll do is I'll go to here, and you'll see that 60 degrees is there. Okay, so it's about 0.866, and then if we go to 120, we're looking at 0.866, the same. Okay, so if you can put that in your calculator for decimal value, but it is exactly the same. And graphically, I guess you can see that when it is 60 degrees and when it is 120 degrees, the Y value is the same value. Okay, here we have our range from 0 to 360, and there is nothing else in the way that's going to represent the same number. Okay, so going back to here, so we'll just say that X is equal to 60 and 120 degrees. So for something like that, it's fairly simple and straightforward. With cosine of 2x, it's a little bit different. And so, but we'll have the same approach, okay? So inverse cosine, or in this case here, it's going to be 2x. 2x is equal to the inverse cosine of -1 over root 2. And when you put this in your calculator, you'll end up getting 135 degrees, okay? Okay, and then from here we'll have divide both sides by 2. We'll end up getting 67.5 degrees. So that's going to be one solution. There are multiple solutions here. If we look at our calculator, and got it prepared here. So again, if you type in the function cosine of 2x into the graph, and you go into menu, window zoom, window settings, and recalibrate your x and y axis from 0 to 360 for the x and -2 to 2 for the y, you'll end up getting everything kind of fitting in nicely. You'll notice that because we've got cosine of 2x and it's not cosine of x anymore, that is going to double the frequency. So we've got two cycles happening within the same period of time. So I'm going to be jumping to the other one here, just to kind of show you on a bigger platform of what we're looking at here. So again, we've got 0 to 360, and we can see that there's two cycles happening. All right, so where we have 67.5 is about there, okay, and we can see that there's one spot, and then there's another spot, and then there's another spot, and there's another spot. Okay, so going from this point to this point, we need to add 180 degrees. Okay, so 180 degrees because it's double the frequency, it's half of 360. So let's go back here. So plus 180 degrees is going to give us 247.5. So the other option is 247.5 degrees is our second. We know that there's four solutions. So I'm going to put 67.5, I'm going to put a gap, 247.5, and then another gap, because we can definitely see that there's two other options. So from 67.5 over here to here, we're actually looking at 45 degrees angle, okay? 45 degrees going across and 45 degrees going across. Using the graph, even using your calculator, your graphics calculator, what you can do is you can go to menu and you can click trace. And with your direction pad, you can actually go around and move around following the different key points. You don't have to trace, and you'll probably get more accuracy as well, but this is a quick function to get there. So going around, so what we'll do is we know that it's 45 degrees going from one point to another point, and then from that point to that point. So what we'll do back here is we're going to add 45 degrees and add another 45 degrees, which will give us 112.5 degrees and then 292.5 degrees. So that will be our four solutions for cosine of 2x, working out what x is. All right. So hopefully that helps you with this part of the chapter. That ends it. We'll move on to revision, and let me know if you have any questions. All right. See you later.